In this video, we're going to build on what we talked about in the last video when we assign R and S. Notice the third step whenever we assign R and S is that we had to make sure that the lowest priority group was going away from us. Well, what if that's not true? Okay, what if we're given the molecule and the hydrogen or whatever the lowest group is coming towards us? We need strategies to deal with that. So I've got 3 strategies listed here, and I'm going to walk through them one by one, and then I'll make another video that kind of does a little more practice with that. So this isn't repeating the problem. The crux of the problem is in all the videos, or in all the examples in the previous video, the lowest priority group, the hydrogen usually, was going away from us, and that is necessary when assigning configuration that the lowest priority group is going away from us. Well, you could very easily be given a molecule that looks like this one down here at the bottom. Notice how our lowest priority group is a hydrogen, and it is coming towards us on a dash. And so I've built that in a model right here. You can see right over here. Oh, you can't see that. I'm sorry. Right here. Okay. The hydrogen is coming towards us, and the oxygen is going away from us. Well, hydrogen is our lowest priority group, and it's coming towards us. We cannot assign R and S with the hydrogen like that. We need to do something else. So here are some strategies. The first strategy is that you could just build a model and use that model. So that's what I did here. I took a model, I built it, and I'm going to show you how it maps onto the structure we give you. So this structure has a chlorine on a line, and then a CH2CH3 also in the plane on a line. On the model, this is that. You can see I'm running my cursor over it. Green is on the line. This is in the plane with that, the CH2CH3. Okay. Then on a wedge coming towards us is this hydrogen. Down here on the model is the wedge coming towards us and pointing down a little bit towards us. And then going back and away, the OH, see how that red ball is going back and away, okay? So this model tracks, but the problem is the hydrogen's coming towards us. We cannot assign R and S when it's like that. So all I did was I took this model in my hand and I turned it around, putting that group, that hydrogen, all going away from me. So now the model is perfectly useful for what we need to do. We can assign priority. So we know chlorine is the highest priority group, oxygen, and then the CH2CH3. Our lowest priority group is that hydrogen, and it's going to the back. So I take my cursor and say I'm going from 1 to 2 to 3, 1 to 2 to 3. So I'm moving my cursor in a clockwise fashion, right? So this is an R configuration, okay? We've just taken the model and we've just viewed it from a different perspective. Now what I'm going to do is I want to go through these other 2 strategies with the same molecule. And remember, it's the same molecule. I'm not changing anything about it. This is the molecule. This is a configuration of R, and the answer on the next 2 slides is also going to be R because it's the same molecule, but we're going to show you how we get to R using these other strategies. So another strategy is to redraw how you would rotate one of these single bonds. So for example, I'm looking at my molecule and the problem is that this hydrogen is coming towards me. It would be very nice if that hydrogen was represented on the dash going back. That's what we've seen before, right? And that was really easy. So we need to redraw our molecule to get it doing that. So what I like to do is I like to take the framework of the molecule and just draw 2 lines, the dash and the wedge, so it maps very closely to what we see above. And then I'm going to figure out what bond I need to rotate. Well, it'd be really nice if we rotated this bond. I will highlight that bond in blue. I really want to rotate that blue bond, okay? And that blue bond would map to right here. So when I look at what I'm going to have over here, I'll still have my CH2 and my CH3 here. Hold that part the same. I'm just rotating this bond. It'd be really nice if I moved my hydrogen back to my dash. So I'm going to do that. Hydrogen back to the dash. Well, I'm going to take the thing that was on the dash and move it up here to the line. And then the thing that was on the line, I'm going to move it down and put it down here on the wedge. So if you were to build this and see that, you're physically rotating around that blue single bond. You're moving the thing that was on the wedge moves to the dash spot, this dash spot moves up to the line spot, and the line thing moves down to the wedge. So my hydrogen moves to the dash, back, here it is, My thing that was on the dash is the OH. It moves up to the line. Here it is. The thing that was on the line was the chlorine, and it's going to move down to the wedge spot. And there it is, the chlorine. So I haven't popped anything off. I have only rotated my molecule around a single bond. But this is really convenient because now my hydrogen is going back. And so I can take that information and assign priority. Chlorine's priority 1, oxygen's priority 2, CH2, CH3 is priority 3. Remember from the last slide, this is the same exact molecule. Nothing has changed other than rotating around a single bond. We've made a conformer of it. It was R before. We better get R here, and we do. Going from 1 to 2 to 3, 1 to 2 to 3. My cursor is moving in a clockwise fashion. That is R, and it's okay to assign configuration right now from 1 to 2 to 3 because my hydrogen is going away from me. And that is what must be true when you actually do your assignment of 1 to 2 to 3, R or S. Let's look at one more strategy with the same molecule. So another strategy that it's a little bit trickier, which is why I left it for number 3, is to actually pop 2 groups off and swap them to make this easier to deal with. However, there's a caveat at the end. It's a little tricky. So here's what you can do. Think to yourself, okay, well, my hydrogen, my hydrogen is coming towards me, and it'd be really great if it was back here, right? It'd be really great if it was on the dash. So that's what I'm going to actually do. I'm going to pop off these groups and change the molecule. I am going to pop off the hydrogen, and I'm going to put it back there, and I'm going to pop off the OH and put it up here. Notice I have left the chlorine and this part of the backbone the same, okay? This part of the backbone has not changed. I have just popped off, which is technically illegal. You can't just start popping things off. I've popped these groups off and swapped them, okay? But this is convenient because now my hydrogen is going back. That's what I need it to do. So let's assign priority really quick. 1, 2, 3. And we look at our molecule and say 1 to 2 to 3, 1 to 2 to 3. What direction is my cursor going? 1 to 2 to 3. It's going counterclockwise. It's going from 1 to 2 to 3, back up to 1. That's counterclockwise. Well, that would be S, okay? But we know this molecule's R because we've already done it multiple times. You have to switch if you swap 2 groups like we did, we popped off the OH and we switched them, you also have to switch this configuration around at the end. So the answer is R. When you swap 2 groups, you have to swap R and S at the end. So maybe this strategy works for you, but you really have to remember, did I rotate around the single bond? You don't switch the R and S at the end when you do that. When you swap 2 groups, you do switch it at the end. So maybe take all of this and kind of practice, pick one strategy that really works for you and use it all the time. Whatever that is, just make sure that you're practicing it a lot and you know what to do with each strategy, okay?